Hi guys, it's Marco from Donut Lab. You are watching our battery proof series called I Donut Believe. In this series, we demonstrate the capabilities of Donut Battery, which is the world's first solid-state battery used in production vehicles. Today's topic is safety demonstration tests. When we released our high-temperature test, we mentioned that the pouch had broken and lost its vacuum at the end of that test. These industry-standard pouch materials are simply not designed for the 100 degrees Celsius that our batteries can take. A lot of you picked up on that, and many assumed the cell must have started decomposing or even gone into thermal runaway. So in order to demonstrate how safe our battery really is, we took that same damaged cell and just kept cycling it. Obviously, the cell is damaged, but even then, it remains completely safe. Any lithium-ion battery in this condition would simply catch fire, while the donut battery just returns an error message. Let's go and watch the test.
Thanks, Marco. This test was conducted by VTT, which is a government-owned technical research center of Finland. The full report made by VTT is available for download at idonotbelieve.com, so let's dive in. You might have noticed at the end of the previously released high-temperature report that during the 100-degree test, the pouch surrounding the cell's active materials had lost its vacuum. This particular cell design uses pouch materials and adhesives borrowed from the lithium-ion industry, and as you can see, they are not designed to continuously operate at 100 degrees Celsius. If this kind of pouch failure happened to a conventional lithium-ion cell, the result would be catastrophic. Lithium-ion cells cannot operate when the liquid electrolyte leaks out and active materials come into contact with oxygen. And even if a lithium-ion cell somehow survived the pouch failure without catching fire, the likelihood of it going into thermal runaway significantly grows the moment you start charging and discharging it again. To prove that the donut battery continues to operate safely even in this state, we took that very same cell with the broken pouch and started cycling it. To be clear, these are not normal working conditions for any cell, and this is not a life cycle test. This is a test to prove that the cell simply does not catch fire even when cycled with a broken pouch, something that conventional lithium-ion cells simply cannot do. Now let's jump into the report and see what happened. The test started with 5 standard 1C charge and discharge cycles. And as we can see, even with the broken pouch, everything looks completely normal and the battery is operating as it should. Then the cell was fast charged at 5C rate for 50 cycles. Here we can see how the cell keeps working in a safe manner even though the capacity starts to drop early in these cycles. The capacity stabilizes to around 11 amp hours, and in the final 5 1C cycles it actually even regains some of the capacity. The cell continues to operate safely with no spikes in temperature and with no risk of catching fire, even after being clearly damaged, having increased in thickness by around 20% and losing half of its capacity. What this means in real-world use is significant. In this type of a failure mode, the donut battery fails gracefully with no harm to the user, and demonstrating it handles this sort of a scenario far better than conventional lithium-ion batteries.
That is all for today. Thank you for watching, and the full report is available for downloading at idonotbelieve.com. See you next time.